Welcome back to this week's episode of Tcast. Yeah, it's cold.
Nice hat there, bro.
It's cold.
It's Albuquerque. It was what? Yesterday I was sweating when I was running.
It was 90 something.
90 something. Today, literally, right now, what is it? 52?
48.
48.
Statistical anomaly, huh? That's weird.
Yeah, it's as old as I am. The weather.
Yeah. No, that's weird. There's an outlier here.
Yeah.
And should we change how we think about what tomorrow is going to be like, depending on the data we've received today? I don't know.
Look at you, just rolling right into the topic today. So smooth.
What I want to talk about is from a statistical standpoint. A lot of the artificial intelligence, stupid term, a lot of the machine learning, deep learning systems that are in place, they use a statistical method called Bayesian statistical models. And I want to talk about how that Bayesian model has some fundamental flaws in it. And the reason this is important because as we're, ingesting so much data and analyzing it, if we're applying a model that's fundamentally flawed, you can yawn.
No, I don't need to yawn. No. I was thinking about, I have a Starbucks. So I was thinking about.
Tell me.
I was thinking about, I need to drink some Starbucks.
I didn't know that was your thinking face.
Yeah.
I actually have a Starbucks cup. Look at that.
Look at you.
Oh, look at that.
Well, you know what Starbucks
Captain
is from.
Starbucks.
Yeah, exactly. The mermaid on the front of the ship, Moby Dick.
Did you ever see that original movie?
A long time ago.
Dude,
it's kind of creepy.
Pastor just giving that speech.
Oh yeah, that's how it was.
The New Bedford whaling town or wherever it was, dude. He was out of control.
But that's how they were all the time. They even had those spiral. You've seen in Massachusetts. They even had those spiral pulpits.
Yeah,
and they would just rain down fire.
I wonder.
People would. I got to tell you. So there's a guy that brought revival into the area where you're from, named Jonathan Edwards.
Okay,
and he did a sermon called Hands.
John Edwards, the guy on the TV show that talks to spirits.
No. He did no. This is the Jonathan Edwards. He did a sermon called Hands of an Angry God, and so the whole thing was just fear based. Super.
I'm sorry. It gets me every
No, I know but I mean, it was like super fear-based, yelling, screaming. They said that people were grabbing on, the pews, the wooden oak pews. Yeah. People were grabbing onto him, holding onto him, screaming because they felt like they were going to go to hell. No lie. You should read about it.
I don't doubt it.
It's called so what happened was, in this time frame, late 1700s, early 1800s, it was called the Great Awakening. And then it came through.
I don't know if that's an awakening or like shutting.
But there was a good thing because we always look at good things. So there was a good thing about it. Before then, and we'll get right into our theory. But before then,
our fact.
Before then, people never experienced any emotion in church.
Oh, that's interesting.
So like the Quakers came, and then the Shakers, and then so now there became this. I can feel something
good
emotionally. Yeah, amazing furniture. Yeah. But it was like there's an experiential part to myself as far as and what I can experience with a God or however you want to look at it. But we're on a TARTLE episode.
Yeah, and
higher density living. So let's go to all your notes.
Yeah, so all right, so let's look at this here. So when we consider a world of statistics, we're going to use a basic model of the coin flip. And when you and I look at this, or anybody else, if it's like the NFL, we're trying to decide what part of the field, who gets the worst. I don't know shit about football. I don't know why I used that example. Yeah. That was such a bad idea. What happens on the coin toss? Can you walk me through it?
So what happens on the coin toss? Usually the quarterbacks get together and then they
and they're quarterbacks. The captains, that's funny. Yeah. The quarterbacks toss the quarter.
Yeah, because then they flip the quarter and then they call out. The team would call out whoever would call it heads or tails, and then that's where that team gets to start if they win.
Okay, got it. All right. So, in order for that whole thing to even happen, both teams have to come together and the ref,
right?
And we're all under the assumption that coin is a fair coin.
Yes,
it's balanced, and we all we believe because we're eradicating, obvious things that happen in nature and physics, and we just say, okay, that there's a 50-50 chance.
Yes.
That's not true. Okay? That's fundamental flaw number one. The coin may be perfectly balanced. And if it is, that would lead you to a higher probability that there might be a third state in which the coin can land, completely balanced. So from that beginning point, when we look at our current statistical models and how we are actually analyzing data, right, from an observational standpoint, because this is all about observation. That's what statistics is. If they do a poor job with cause and effect, they're just like, let's observe and then kind of go back and say, oh, maybe this is what happened, or this is what will happen.
Past indicators.
Yeah.
To predict future outcomes.
So in a regular frequentist, it's called frequentist statistics model, means that we're just going to flip, and over a long period of time, the more times we flip this quarter, we should see that the probability comes down to a nice even 50-50 split.
Right.
That's assuming two states, right? But it doesn't happen like that. Maybe after 20,000 times I end up flipping the coin and it does land on its side. Well, now I've just destroyed the probability of my entire model. It can never be a perfect 50-50.
No.
So when the statisticians were looking at this, they're like, oh, we need to change this, right? Something could be off here. And that could be that as I begin to flip the coin, maybe I start to get more heads, than tails. So maybe we actually need to refine our theory every single time we flip. So in the Bayesian model that a lot of, computers have adopted is the idea that as time progresses with your variables, so every time you flip the coin, you go back and you check it against everything that's happened in the past, and then you redo your theory of assumptions every single time.
Right.
But every time they redo the assumptions, the assuming the probability of it, they always assume that it's going to be a binary state of either heads or tails. They don't assume that maybe I'm flipping it in a frictionless environment like space, where the coin flips forever, right? It doesn't land, right? Or, I flip it in the air and it lands, on its side.
I think another perfect example is craps with dice.
Yeah.
And they will actually get rid of, they check the dice, weigh the dice, make sure everything's perfect. But for some reason that there could be a set of dice that just hits threes, and they've checked everything. They don't know the reason why.
Correct.
It's just hitting threes. And how do you explain that anomaly?
Yeah. And then you're trying to understand like what is actually going on here. And only if we have an infinite amount of trials,
right,
can we guarantee 100% accuracy. So in statistics, we have to do things an infinite number of times, but we don't have enough time to do that. But fundamentally in our models, we apply these Bayesian models into our machine learning, saying that, okay, we're just going to take our best guess.
Right.
And we're going to continue to keep refining that best guess on observations.
Or allowing that machine to flip it, 10,000 times in a millisecond.
But the thing is, they continually flip that thing on a false fundamental principle that there's only two states of outcome.
Exactly.
When the problem is there's an infinite number of states of outcome. That's the crazy part about it. It all depends on the environmentals, right? So there's a complete disregard for the natural happening of cause and effect. So when we look at, the attributed probability of flipping that coin, right? In the first case, in our old statistical model says, okay, we're going to observe 50-50 because that's an assumption, we as human beings say that the coin is fair. We haven't done all of our measurements and we just say there's two states, right? Heads or tails. And then the Bayesians came in and they're like, okay, I know that if I flip this coin, say 10 times, then if I get 6 heads, then that should preclude a 40% probability of me getting, tails. Well, then what they do is they neglect the idea that their assumption is false, and they retune the theory every single time, or the hypothesis on what the probability of the outcome is. So what it's doing essentially is, if you're plotting all these random variables across a chart, what they're trying to do is they're trying to normalize this curve.
Right.
So in the first set of statistics, it's like, okay, I see random variables and hopefully it follows my line.
Over
right?
time, it will.
Over time, it's going to follow this line.
Right.
It's not going to be perfect. But what the other people do in the Bayesian is like, how do we take the outcomes that are flawed and try and round out our flaws into a nice curve so that reality fits into our model rather than us fitting our model to reality. And so at the core, when we are using, machine learning with data, we are trying to mold the reality that the system is saying is reality to how we operate as human beings, which is fundamentally opposite, and it's already fundamentally flawed. So the the consensus here is this. Jason, there was a guy who used to run an inn. He was an innkeeper. This is a little tale, right? Little fable. And he only had one bed in the inn, and it was only one size. And so what would happen was when someone would come in and ask to have a bed for the night and say they were too large for the bed, he wouldn't resize the bed or get a bigger bed for them. He would just cut their legs off so that they fit to the bed.
Right.
And that sort of thinking, that sort of Procrusty Bed, I think it's called, that idea is currently what we're doing right now, is that we are cutting the legs off of reality and nature and forming it to our rectangular box of how we assume this is how the world should work, what everything should fit into. But that's not how the variables actually come into play. So because of our fundamental starting flaws, with a complete lack of disrespect for how things truly operate.
I'm picturing a guy with his legs cut
No,
off.
you are, and as you should, because these.
Yeah, I know. It's very extremely demoralizing to the human.
It's demoralizing to the human.
And that's what I'm thinking, with the data too.
Sure.
It's because whenever I have to take you with your hat and your flannel shirt and your, cool Casio watch and I have to put you in a box, it's an anomaly. Like you said, you've never bought a pair of jeans.
Yeah.
Where if people looked at you, they'd be like, oh, he's probably but I have probably 40 pairs of jeans in there, and people would look at me and say like, what
about me buying shoes?
They would assume you would buy jeans over me.
Yeah.
Where you've never bought any and I buy a ton.
Right.
So you have no idea. And I like the model that you said that we had talked about last time, where those security cameras were taking black people. Yes. And then the machine learning was actually being extremely racist.
So that was the person who wrote the algorithm. That was their model or perspective of the world, right? And it was a flawed one. It was a binary state. It was either this or that. There was no in between, right? And so the lack of flexibility, the inflexibility, we're putting all of this money and resources into this machine learning when at its absolute core is it's fundamentally flawed with how we're using to analyze things. And it's only in a state of pure observation. It's not really that intelligent,
right?
Because all it does is look at something and then create a theory it's not even creating any causes yet, right? It's only looking at effects over and over and over and over and over again and saying, oh, I'm going to continue to retune my theory and see if it fits into this model that I plug in every single time. Rather than we should look at data and machine learning and put it in a system so that it actually creates and analyzes causes and effects.
Right.
It's only looking at effects, and it looks at effects through a fundamentally flawed view of the world in the first place. So, we have to be careful when we use data, right? And then we plug it into these systems because these inherent biases can lead us in a bad direction.
Oh, I mean, AI would tell us right now to solve world problems, get rid of a third of the population that's poor.
Yeah, no, it's easy.
Let's just kill all those people.
So if we let's look at something obvious, right? There's only so much, what do they call it? Arable land?
Yes.
I don't know, is that land that can be farmed?
Yes.
There's only so much arable land on the earth, right? And if you look at the required amount of living space for a human being, the calculation says 550 million people. We have 8 billion.
Yes.
So for the AI, it's like, oh, basic calculation. This is my model of how I think things should work. Get rid of them.
They're exerting this much energy.
Yeah, they're exerting this much energy. So the issue is AI doesn't look, and that term, that buzzword, AI does not look, or we do not give it the eyeballs to properly analyze cause and effect. It's just stuck looking at effects, and it gives us these totally obtuse, ridiculous answers to something when it fundamentally was, had an incorrect, like Coke bottle glasses that are way out of focus.
Yes, exactly like mine.
Yeah, exactly like yours. So when we move into the future and we start to pull data from a human aspect, purchasing it for people on TARTLE, we would hope that the people analyzing it take into a fundamental understanding of the cause and effect, the flexibility of a human being, the dynamicism of a human being, and then apply that into their algorithms, right? The algorithm lacks flexibility. These, Gaussian statistical models or Bayesian statistical models, they lack flexibility. They're inflexible. And that's just not how nature works, right? If nature is out of balance, it balances itself back out, right? It'll burn itself out over here, melt the ice, do whatever it has to do. So we're going against a lot of fundamental things that happen naturally. And to say that this model, which is so unnatural, is driving a lot of our machine learning, that's quite worrisome.
Yes. I mean, it's fine if you're looking at x-rays and trying to pinpoint anomalies that may be in a lung.
Sure.
And you're looking at millions and millions of x-rays and having a group of doctors looking at that would take forever, where a machine could do it in 5 minutes. That's great. That's amazing. That doesn't require a consciousness.
No, that's machine efficiency.
Yes.
That's making the processing time faster.
Yes.
And people don't realize that
that's where machine learning is great.
That's where machine learning is great, is making processes, doing calculations quicker. What it's not good at is recognizing cause and effect.
Yes.
You know who is good at doing that? Human beings, right? Because we're the ones that create the causes, right? And if we can witness the effects, or even write into some sort of algorithm how to visualize what the effects are off of our causes, now you have a totally different structure.
But that's at least 50, probably 50. When you talk to AI scientists, they're like, we are not even close.
Well, the thing is, it's also a big perspective change.
Yes.
And a lot of the investment money for machine learning and AI, and all that push you see on LinkedIn and all that other crap, it goes to, just efficiency of tools and processes that are already in place. It doesn't actually go towards enhancing the evolution of our thinking and our actions.
So what makes TARTLE different when it comes to us analyzing data?
That's funny. What they're going to realize is that as they begin to, these people buying this data and analyzing it, human data, qualitative and quantitative, in order to have both of those put together and analyze them properly, you can't use these old models that we're bound by. They're never going to work. So it's actually going to end up forcing people, right, scientists, to re-look at these models and actually how we view the world, and stop looking at it such a rigid and finite way, and actually look at it with the flexibility that it deserves, right? The nuances that each human being has. And if you can create, a sense of machine learning that fits into that sort of perspective, well, now you're doing something really valuable. And then you'll be able to create so much goodwill with your decision-making and effective value off of that data you're actually purchasing. Because it doesn't make sense to, like I said, it's like you're the innkeeper, right? And you're buying all this data,
right?
But you keep having to chop the data up because you think this is the model that works. Is that a good metaphor?
No, I think that's good. And it's like, it reminds me of the old days. Remember the Nielsen ratings?
Yeah,
and all that.
TV,
and then they would poll people to see, and they would put like a $2 bill inside there, and then people, but what they found out over time was the people that would actually accept the $2 bill and fill out, were people that were made stay at home, that are older in age. And so then it when you think about that, it skews the data dramatically because, now Price is Right is number one,
yeah, exactly.
Or Judge Judy or, but the person that is busy working, doing what they need to do for life at 30, 35, 40, there's no way they're going to spend 5-10 minutes to fill out a bubble survey.
No, they would.
We can't even get people to vote.
Yeah, it wouldn't work. And that, that reminds me, I think we brought this up in an old episode, and we'll just close on this about how the data is skewed, right? So you got skewed data, and then you got bad models, fundamentally flawed models. But that's running everything we do in society. Yeah. I was down in Disney World recently, just checking it out. I think I went there to get dinner. And as I'm leaving the park, there's a gentleman standing in like the doorway before the parking garage. And he's got an iPad. He's got like a little jacket and it says like Disney Research or something like that. I don't know what it was. And he would ask randomly people, as they were coming by, if they wanted to fill out a survey. And so I went up to him and I struck a conversation. I was like, how many people actually, first of all, receive your attention? He's like, maybe less than 20%. Okay. And then I was like, from that, after you've gotten their attention, he said, how many people actually want to stand there with you for a couple minutes and fill out the research thing? He said, less than 10% of the people, right? So we're looking at 2% of all the people that walk by. And so the 2% of the responders, and I said, now, are these people that are already precluded? Do they give you a lot of good feedback or is it typically negative feedback? He said, well, the 2% that we receive is typically people that have had a bad experience.
Right. And they want to be able to voice
and they're like, I want to voice it. What about all the good experience that walks by?
The 98%.
So now you got you've you have 2% of the people walking by. The data is completely skewed. And it's just angry people giving you information. How are you even supposed to know? And then Disney plugs that into their models and they're like, look at us.
Yeah.
We're doing great. No wonder why it's like such a coked out happy playground, right? Because it's like you have to medicate everybody because they're so upset.
Well, I think they're like pumping, they've got to be pumping some type of,
I don't know, the smells in the air.
Yeah.
The churros. I'm walking around, there's like smells of churros everywhere.
Churros. We got to end on that.
Yeah, we'll end on the churros. But listen,
we've gone 20 minutes.
Yeah, I would listen. Don't take our word for it. I would encourage you to look at the, Bayesian statistical models, machine learning, and look at how, we are form fitting the world to our false reality.
Yes.
All right, cool deal. Thank you, everyone.
Yep. Thank you.